Alright, let's get started. Welcome to the stream for those guys watching. Today we will continue the work on Juniper from Schema. The library that we've been working on for a couple of streams now. Juniper from Schema, to those of you who are new, is basically a thing that lets you, it's a procedural macro mostly, that lets you generate a bunch of code for using a GraphQL library called Juniper with Rust. So it takes a lot of the boilerplate away and lets you use a normal like GraphQL schema. You don't have to have everything be in Rust, which is very nice because you can then share that schema with other clients and such. So last time we finished our work on making query trails work for interfaces and union types. And so I left it as a PR last time, and I've since then set up Travis. So I think we might actually just go ahead and merge this into master. I'm going to take a look at the changelog first, because I don't believe that we mentioned anything in the changelog regarding that. Yeah, so we wrote that query trails work for interface types, but they also now work for union types. So I think like the other thing that we're going to work on today is allowing you to customize the error type. I'll talk about why you want to do that shortly. But I think we might as well put this fix, the union type fix, and the customize the error type feature in the same release. So I'm going to leave this here in the changelog and then just merge this into master. So I have a macro or an alias called GMF that just takes a branch and then lets me like fuzzy search and then merges that into, like, that becomes sort of the argument to the merge command. But I'm not actually sure which branch I picked. Query trails for union types, that seems about right. Yes. We'll go ahead and push that. I just put CI skip on the build since we just updated the changelog, and then we don't need to actually update the build. Let's just run the tests again to make sure everything works. I have some coffee here to stay awake. While that runs, this PR should close, and it is closed. That's sweet. Test still pass. Let's go ahead and just nuke the branch. Nuke is another command that I've set up that just deletes the branch locally and also any remote branches and the tracking and all that stuff. And the issue should be closed as well. And it seems that it is. It's very nice. So now let's talk about this one. So currently, if we open up the end-to-end test, you can see that the error type, or rather the return type from all these field methods, is a field result. And if we open up the Juniper docs for this guy, that is a, let's go to the latest version. That is basically a type, an alias for a result of some field error. So this is the type here that we would like for you to be able to customize. Currently it's always field error, but you might need it to be something else. And the use case there is that there is a trait called into field error, which any type that implements this one can be used as the error type in a field result. And so the use case for me in particular is that I have this other project that I work on for work, which is sort of the testing ground for this Juniper from Schema. And what we need to do is when some sort of error happens in our GraphQL pipeline and query evaluation, we need to track that, in our case in Rollbar, which is an error tracking system that we use. And so basically what we do is we implement this into field error for our error type, which will track it in Rollbar and then do a very simple conversion for us. So this is the use case that of why you might need to customize the error type. And the syntax that I figure we could just go with is simply only allowing it for the macro that takes a file. I don't see why you would need it for the one that takes a literal schema, since that's pretty much just for testing. And then just having this syntax here for customizing the error type. So what that means is, if we open up so the way that we would actually go about doing this is, so this is the function that gets called, GraphQL schema from file, which takes some token stream, and you can then say toString on that, and that gives you back a string of like exactly this, as if it was a string, and then you can just process it in any way you want. So basically what we do is we fix some quoting issues, and then we just like read that file. So what we need to do is somehow accept this as optional, and then default to using the default this one, the field error by default. So I figure yeah, and so the function that actually generates all the code is this parse and gen schema that takes a schema and returns a whole bunch of Rust code. So I figured what we should do is this guy that actually generates the Juniper code. This function lives in here. Currently, it always uses field result. I figure we could start by changing that to an explicit to an explicit result like this. That's going to be very straightforward, and then we can work with replacing this field error with something that gets passed in. And once that works, we can then actually customize what gets passed in. So we'll sort of start from the bottom and then work our way up. And the reason that we are going to do it that way is sometimes it might happen that you need to do some task and then you start at the highest level, and that bit is easy. Say for us, it's parsing this string, which we know we can definitely do. That's going to be some regex of some kind. But we might hit some wall with like some lower level that for whatever reason doesn't work, and we have to spend a whole lot of time on that, which means that we might actually have to design this solution differently. Does that make sense? Hopefully it does. So we're going to start by replacing this with the regular result type that comes from the standard library. I believe it's just in result. Yep. And we need to return this one. Extern create std is private. What? Is that because you need that in front? Oops. It seems that we were maybe a little bit too fast in our replacing here. Compiles. Let's see if the test still pass. And as always, if there's any questions along the way, just put them in the chat. test pass, which we would expect that. This was a fairly simple change. So now what we need to do is somehow customize what error type this is. So somehow the top level function here needs to take a error type, which is some sort of identifier. Which means that we need to update this in here. Let's say this is error type, which first is just we need to make an identifier of some kind, and I have in here I believe I have a function called ident. Yep, that just takes something that is a string type thing and turns it into an identifier. So we'll just use that here. And to begin with, we'll just use field error. Should work. It does, but we're not actually using the variable yet. Let's just turn off the dead code warnings for now because they are a bit annoying. Juniper field error is not a valid identifier. Why not? I guess it's because it's not actually an identifier, but the name of a type. Does that make sense? Let's try to find the documentation for syn ident. Type path. Type param. A path like std/either optionally qualified with a self type. Is that what we want? How do you make one of these? Parse stream. Path. Let's remove this one. Type path. Can you do this? Whoops. Result. Token stream. So we're just somehow trying to make one of those type paths, and I noticed that there was there's a thing called parse from type path for type. What is that? Send type tuple path. That you're somehow able to parse one. And parse is implemented for token stream. Import parse. A parse stream. What the hell is that? Hey, MightyCore1, thanks for the follow. Is there anyone in the chat who has experience doing stuff like this? Because usually you just use the quote macro, and then you put your Rust code and you build it in there. Does it make sense to just do that? Impl parse. Let's read what it says. Parsing interface implemented by all types that can be parsed in a default way from a token stream. How do you get a parse stream though? Parse buffer. The parse macro input. Calling a parser function. Parse buffer. How do you get? Can you get one of those from a token stream, or can you just make these directly? Call arrow fork. Like so you can do stuff like but that means that this is just a token stream and not an actual type. Like it's a token stream, it's not one of these type paths, but I guess that'll work. That just means that this guy will just take a token stream instead, which is a bit, what is this? We have no idea. But I think in the order of just wanting to make progress, I think we'll do it that way. If there's someone in the chat who knows a bit more about how to actually do this, that would be great. Sin quote. At least I think so. No, it's in quote. And we're back to building. Alright, so now this stuff works. Now what we basically have to do is pass this guy into whatever method needs it. So I think how it is, like the easiest way to do that is to actually find all the places that need it. Just to be safe, let's change this to Juniper. And I say that here we're just like, we just have an error type and we don't know where it comes from. And then we'll just say that it comes from this guy. Which means that whoever calls this has an error type. And so that comes from here, which means this function passes in the error type. Oops. And we should almost be at the top now. Yeah. Yeah, we should probably make it a reference. And then we just keep doing the same thing. Everything that takes a field error instead gets the error type, which it already has. That's easy. Is that the last one, or was there one more? One more. Oops. This code is not the cleanest in the world. Like you see, this is like, here we have about a 100-line function, but it's not too bad. I haven't had the need to really extract much yet. Types differ in immutability. Wait, let's pay more attention. Where were we? Yeah, so I like having the error type being the second last when it takes an output. Expected token stream found reference. Makes sense. I think that was the last one, right? Yep. Let's run the tests. To those watching, is the font size okay? It's not too small. I used to do these streams in 720p, but I've been watching some of them back on YouTube, and I felt like the quality was a bit too poor. I think the font size was fine, but I might be wrong. Yeah, so I think we should just commit here. So now basically what we need is somehow like parsing the there's a thing that worries me a little bit. I just think like if we parse this stuff would come out as a string, right? Can you do this? Would that still work? No. I thought so, and you can't say either, because that's what we tried before, right? That's annoying. Yeah, GraphQL. It's really awesome. We've been using. So I work at a company called Tunter, which is like a social network for football players, kind of thing. And like our main backend API is REST. It's a Rails app, but I've been very interested in GraphQL lately, and I also want to. So since we're in Ruby on Rails, we're using Ruby, but I also want to make the jump to Rust. So it seems like Rust and GraphQL together with all the type safety that you're able to get seems like a great fit. But this is annoying. That means we need a type path anyway. Is there some way to just like parse a string into a type? There might be someone else who has a similar problem. Sorting paths always is painful. Parse. Huh. Can we do this? Field result. Field error. What? Do you know how to fade out an image so the left is transparent and the right is visible? We're not really doing web development here, but I suppose if it like if you know the image up front, you can just make a half transparent PNG, but how to do it with any image, I don't know. That works. That also works. Let's actually just pass that in instead. Yeah, I thought so. So the parser that we use to parse GraphQL has a type called type, so this is conflicting. So we'll have to qualify this one. That means that all these tokens need to be certain type instead. I'm hoping that you can just stick those directly into a quote and still have it work. Seems like it. So that works. Now let's keep the lib open. So I like to commit often, even though our work is not done, because we can always squash our commits later. But as soon as we've made a commit, the work is saved in Git and can't be lost, even if we reset or do anything basically. So now all the stuff is basically done. Now we just need a function that can parse this input and give us back the file name and which error type to use. So let's write that next. Let's make a new module for it. Parse input. So it needs to return something that has a synt type and a string. I'm just thinking right now, I'm not sure if this is the setup we'll end up with. So it needs a file path, or we'll call it schema path, which is a string and a arrow type, which is one of these types. So what that allows us to do, almost, I guess. So here it actually takes the literal schema, because in one macro the schema gets provided directly like this in the Rust code, and in the other example, in the other version, it's just a file path. So how do we do that? I guess we can just ignore the schema bit then, and then only parse out the... No, that's not gonna work. I was thinking that we could just not return anything about the schema. Like we somehow need to change both of these functions, right? Like this one needs to take the schema and the error type as an argument, so that this function can just pass in the default error type, and the other function, the one that, like this one, can actually call our parsing stuff. I think that is what we're going to do. So this guy, this takes a schema and the error type, just a type, and this one is just the default error type. Let's make that a function in here. How did we get that before? I think we deleted a bit too much. There's this guy. So this takes the error type. This is parse input. No, default error type. This means we need a use for it. Solve. And then this function that actually gets the file can then call this guy. Parse input. Parse input takes the file path, which is the path, I suppose. It probably needs to return some sort of result. I don't know what the error type is going to be yet, so let's just make it unit, which means we need to unwrap it here. Oops. We can work on making the error messages nicer later. And it actually takes a path buff. Wait, no. No, it takes like the literal input to string. Right? And then it does, let's call this parsed. Parsed dot schema path. Path buff expected string. Oops. Whoop. I went too far. I have no idea how hard it is to actually watch someone use Vim. Let me know if you can't follow along at all. So we should be able to take this and put it right in here. We're basically trying to make small steps, change it just a little bit at a time, making sure the types check the whole way. Otherwise, if you write 100 lines and then you run the type checker, you get like 17 errors, and you're like, where do I even start? So this works. At least the type checker's happy. Let's see if the test will pass. And they all do. And just to make sure, we actually have this end-to-end test that actually calls this macro. So that's good. Most of our other tests just use this this macro directly. That way you just define the schema in line. So now we need to actually somehow parse this, which means that I will add a test for this module, and we're also going to need the regex crate. I don't believe I have that already. I actually do. How does it work? Before we think about that, let's add a test for it. Parsing input without error type. So that is something like this. Whoops. If I could Vim correctly, that would be nice. Parse input. And then the path should equal output dot schema path, except it somehow needs to be turned into a path buff. Can you say into? Gotta infer type for T. How do you make a path buff? Path buff from so it returns like the fully qualified path. Let's just say that it contains output schema contains the path. Stir to stir. So the reason is that there is a contains method, I believe, on string, but it doesn't exist on pathbuff, so we need to convert it into it, which you can do with using toStir, but that returns an option, so we need to unwrap it. So hopefully this works. And it did. We haven't actually seen it fail yet, though. So let's just return something random here. Pathbuff from yeah, that actually breaks a bunch of other tests. So let's assume it works. And let's actually get to implementing the real thing. Parsing input with error type. Actually, our input is not exactly correct, because what input it actually gets is it has these extra quotes. That's why we need to replace all of those and just remove them. Let's make sure it still works. And it does not. Why not? Alright. That's because the path is that without the quotes, the input needs the quotes. When will you be buying another MacBook Pro? Whenever they make one where the keyboard doesn't suck. I've been thinking about getting one of the new ones for a while, but I like to buy fully spec'd out machines and then keep them for a very long time. Like this one, as you can see in the description, my channel I've had for many years, and I've had 0 problems with the keyboard. I've replaced the battery like a year ago, and that's just because it was old. And I don't like how much the new keyboards break. I also don't think they feel very good. So fingers crossed they're going to change it this summer. Otherwise, I'm not sure what I'm going to do. I've tried Windows back, not Windows, Linux back in university, but it's not for me. So to stay sane, let's just put this in its own variable. Unsubbed. Why? Because of the Linux comment, or? Wait, so we have to somehow like make the actual type that we expect, right? I have a 2016 MacBook Pro keyboard. It's bad and the keys repeat sometimes. Yeah, plenty of my colleagues at work also have those keys, also have those computers, and they have so many problems with it. I honestly don't know why Apple stuck with that keyboard for so long. Like at work, I use like the wireless Magic keyboard, I think it's called. And that keyboard I absolutely love. That's really nice. So this is cool. Our test actually fails, which we expect because we need to actually like parse out this guy. So now we need the regex crate. Actually, one thing. Before we do that, there's a website called Rubular where you can... Whoa. That used to look different. There used to be like styles and stuff. But you can like... It's just a thing for testing like Ruby regular expressions where you can write... Where does it actually show the output? Is it broken? What the hell? I guess we broke it, or it is broken. Whatever. I was just thinking that we could write the regex first here and then actually put it into Rust, but let's just not bother. It's going to be fairly simple. They have somewhere for how to do named groups. Regex. And the captures, I believe you can just get them like so. Yeah. Whoops. This is super weird. Sometimes when I paste, there's some Vim plugin that breaks something, but sometimes when I paste, it puts this like paste stuff afterwards, and then indentation's fucked and tabbing is reset to be normal tabs. And like, it doesn't fix it to like reload my Vim config. I have to quit completely, and then like now we're back. That's the weirdest thing. Why do you need the R here? Is that because it's a raw string then? Yeah, so usually the way I go about writing regexes is I put in the actual string that I'm trying to parse. How does this work? I suppose we need to use like, what's the syntax for those like raw strings that allow quotes in the middle? Is that it? I think so. So we're trying to parse, oops, something like this, right? So this is one or more not quote. Capture that. I guess this is how you make named groups. Path. Error type myr. Whoops. Yeah, this is annoying. Like, it's this end-to-end test that keeps running. We had that problem at a past stream as well, because like, it somehow builds this all the time as well. So let's just comment this out. You can always bring it back. I basically want to see what matches it actually returns. Same for all of these, I guess. So it seems we do get the path out, but we also get the leading quote, which we don't want. And that's because that is in there. We need it outside. That seems good. What are you complaining about? Nothing. I guess the red arrows were out of date. Test should still pass, I believe, because the error type here happens to be the same one that we use in the test, so the regex should work. Right. So this whole bit is basically optional. How do we do that? I guess we could either make it optional in the whole regex, or just try parsing it with this one. If that doesn't work, then we use one that only parses the file name. I think we should actually just do that. Yeah, let's parse the error type. That's just one or more anything, I suppose. At least for now. And then that is something like this. Failed to parse error type from input into Rust type. Name of a Rust type. Yeah, now our test with the error type actually passes, which means that we are correctly parsing it. But the one without the error type does not pass. Is there an elegant way to handle that? I am not sure. Let's say this is RE with error type without can match that first. So we first match the one with the error type. If that matches, we do something. If it doesn't, we don't really care. Basically do the same thing again. RE with error type, without. So if it does match, then we do this, I think. Type annotations needed for error type. If it doesn't match, like if there's no error type, then we just set the file, and then we set the error type to the default error type. Whereas if it doesn't, then we just panic. Caps does not live long enough. So it was complaining that these variables are bound to stuff that's borrowed from caps. But first of all, it's not the same caps, and out of this match, caps isn't alive anymore. So we need to actually turn it into a borrowed string, and then what the hell's wrong? That's super weird. Like, it was reporting that there was an error and saving didn't make it go away, but recompiling, and now it works. See if the tests also pass. They do, very nice. One thing that I would like to know, though, is that I actually believe that if you if you call to into string on a token stream, I believe it puts in a whole bunch of extra spaces, like the comma and here, and also if you write like more complicated things, like stuff like that. So I think our regex will somehow need to handle that. Is there a way that we can easily test that? I just want to get like as accurate sort of output as possible. And then if we say we panic on that, to string, yeah, as I thought, it puts in a bunch of extra spaces. Let's add a test that parses something like this. Parsing input from token stream. Might as well keep this. And so we'll have to do something similar. The path we don't have. Input we already have. So this should be the type. And the path should contain foo.graphql. And this should fail because we don't handle the spaces in the error in the input. That's not super helpful. So is this assertion that fails? Let's make a debug of output dot error type. Actually, let's just print it. Like, we just need to somehow see what it looks like, right? Can you say to string? Nope. Come on, you know what I mean. Sometimes the compiler is a bit pedantic. Yeah, so it only grabs the first bit. Juniper. What? I guess that's because, so it first tries to match with this one, which doesn't match because there's a bunch of extra spaces. Then it tries to match with this one, which actually does match because like this first half does match. And then it uses the default error type, because what I was wondering was, if we get the output back, you see here it says that the path segment contains some Juniper identifier and a field error identifier. which, like, that is the default error type. So what I suppose we need is a end of string here, and also a beginning of string. And we'll do the same down here. And now it should say that it failed to parse the input. And it does. I suppose we could just remove all the spaces from the input before we run it, but you might have spaces in the file name, so we don't want to do that. How about 0 more spaces, 0 more spaces. I wonder if that does it. Hey, it did. So basically we just, all these places where we know there will be additional spaces, we just ignore those. And any spaces inside the path, that's the user's own fault. So now we should basically be ready to use it. Let's bring back our end-to-end test. So this should still work because it should be matched by this regex. And it does. These should still work as well. So now the question is, where else do we call this macro? Because we need somewhere where we can actually test customizing the error type. So we only do it in the end-to-end test and somewhere in the integration test. Yeah, so let's just add a new test here. Let's start with a fairly simple schema. We'll just copy this one. Non-null scalars. Let's say customizing the error type. This should break now. It does. So then we had a test schemas. Just have some sample schemas that we can use here. Let's just put a new one in here. Schemas. Very simple schema. We basically just need some other schema so that we can call this macro directly, right? Oops. Copy this, paste. And then this should still work. It does. And then let's say error type. Wait, let's change this to be result. Juniper field error. Still should work. Let's define our own error type. My error. error type is my error, and it should now complain that this type signature doesn't match anymore. It did not. Why not? See, this is why we add tests like this, even though, like, you might have thought we were done, but we actually weren't, because we had hard-coded to still use the default error type here. That's totally wrong. We need to use the error type. Parsed error type. And that almost made it pass. Yeah, we just need to implement. So Juniper had this into result, into field error thing that we just need to implement. We can just add like an implementation that basically just panics. So impl for my error. I'm wondering if this is going to break it with the spaces. With the line breaks rather. Juniper field error. That's very awesome, it works. So if we remove this now it should complain that this is a Juniper error. First it complained that it didn't parse. Yep, and if we then bring this back, one thing that I would like though is I would like to allow a comma here. But that is not allowed. Let's just add another test for that. Test allows trailing commas. This is a bit annoying because this test doesn't even compile. So we'll have to comment it out for now. And now this actually fails. Allows trailing commas. Let's say that this one with the error type allows an optional comma at the end. Unexpected token. Oh yeah, that's because, I suppose that's because this dot actually consumes the comma. So let's say this is one or more not comma. I don't think you can have commas in types in Rust anyway. Yeah, that fixed it. So if we bring this guy back, it should work now. And it does. Very nice. Awesome. So I think we will just commit this, and then I think we're actually going to end the stream for today. We've been going for a little over an hour. And fun fact, my girlfriend just returned home, and she wants to use this PC, the PC that I'm using to stream with, to play Sims. But I think we're going to end it here anyway, because all we're really missing is customizing and making all these error messages a bit more nice. Otherwise, it basically works. So yeah, let's commit here, and then let the girlfriend play Sims. Parsing input to schema. Let's just say parsing input. Let's push this up and hop over to Travis and just see if our previous builds actually passed. So if there's any questions, now is the time. The previous builds did not pass. Why not? Because we just have to run Rust format. Let's kill this one. And so while we wait for that, what I would like to try is I have a this is the work project that I mentioned before. It basically uses this crate, and also uses a Diesel for the database stuff and Rocket for like the actual web integration. So this is sort of a more fully featured GraphQL API. And currently the way I actually tested this, customizing the error type to see if that would even work at all, was I actually made a commit that just hard-coded to only generate the error type for this particular project. So the error type that we have is just called an app error. And then in this particular version of the crate, it would always use this app error type that just came out of nowhere. But I think what I would like to do is use this commit, and then go into lib and see if that even works at all. Here we should be able to write like this. Error type. Crate error app error. Build again. Oh yeah, it's actually not app error, it's this reportable error. Reportable error is just a thing that like wraps an app error and then actually lets you track it in rollbar. While we wait for that, let's just check on Travis. That is done, it seems. Let's run the test. It seems like it basically worked out of the box, which is really awesome. That gives me a pretty good idea that the code we just the code we actually wrote really works in an actual project, which is always nice. There's one test that fails though. No, they all fail. Am I not running the database? Okay, so this seems to be some sort of... okay, this is a bit involved. But basically, so since the GraphQL project is sort of like our main API currently is a Ruby API at work, so that has its own database, which is then managed by Rails, so that when you, like the GraphQL library then, or service, basically talks to the same database. So running the tests locally, we just reuse the existing database that's managed by Rails. So if you want to change the database, you do that through Rails and not through GraphQL, which is sort of weird, but it still didn't work. Relation error, user didn't exist. Okay, this is not super interesting for you guys to watch, and it's not really relevant to GraphQL. So I will, I'll keep this, but I'll look at that on my own time. But it looked like Travis was done, which means that it actually passed. So I think we're gonna call it here, and then for the next stream, which will be sometime next week, maybe Tuesday or Wednesday, I'm not entirely sure, we're going to look into actually making these error types a bit more helpful. Currently we're just returning result of something or a unit, which is not very helpful. Granted, this isn't a totally big deal because there's not really any consuming code since all this runs at compile time, but we still like to be able to give nicer error messages, especially around this formatting of this input. Yeah, so if there's no further questions, I think we are going to cut the stream here, and then yeah, we're gonna see you. I'll see you at the next stream. Bye, guys.